Today I'm going to show you guys how to make your very own object tracking program using Python and YoloV10 on macOS. Let's get into it. Now if you haven't got a program to code in and you don't have Python installed, that's no worries, it's very simple to do so. So for the program to code in, I highly recommend Visual Studio Code. It's free, it's easy to use, and all you got to do to install it is go to code.visualstudio.com, download for macOS and set that one up. It's pretty self-explanatory. As for Python, Homebrew is probably your easiest bet. And to do that, you just got to install Homebrew first of all. So you get the link they give you on their website. Open up your terminal. Now that you're in your terminal, you're going to paste the code they've given you. Give it your password for sudo access. Oh, do it wrong like I did if you want. It tells you what it's going to do, and then if you let it run. Alright, now that it's installed, all you got to do next is just brew install Python. It already installed on my system, but when you install it yourself, it will do everything for you. And that's all you've got to do. Alright, so now what you want to do is open up Visual Studio Code. You want to open up a new folder. Go to your desktop, wherever you want the folder to, that's fine. Create a folder. So today I'll call it Demo Object Tracking. Press Enter, Open. And now that the folder is open, you want to create your own file. Main.py. So this is just the main file, and .py means it's in Python language. I'm going to create that one, create file. Now, if you've just downloaded Visual Studio Code for the first time, you'll probably be getting a pop-up now down in the bottom right corner down here, prompting you to install the Python extension. I recommend you do so. And if it doesn't pop up for you for whatever reason, just go over here on the side, the Extensions tab, search up Python, and let that thing load, and there's just the top one there. Install that and install the debugger. Now, jumping back to our main file, there are 3 modules we're going to need for today's video. So we're going to need to import CV2, import CVZone, then we're going to be importing Ultralytics, from Ultralytics import YOLO. Now you may notice when you write them down yourself, and in this video here they're underlined, they're all squiggly, that means we have to install them. And the way we do this on Mac is we open up terminal, so do shift control the squiggly button, or you just go up here on the toolbar, terminal, press on new terminal there. And what we're going to do from here on Mac, in order to install these modules, we need to create a virtual environment, because we cannot install them to the Mac's global environment. And the way we do this is just typing Python. So Python will work for some users, Python 3 will work for other users, and then you just do -m. So we're going to make then a virtual environment, and then you want to give it its name. So Python 3-m venv, and then we can call it tutorial venv. So now that we've created the virtual environment, it's going to ask us down here to select it for the workspace folder. We're going to click on yes to that. And if you look up in the top left here, it's got a folder there as well, showing you that the creation's been successful. And now we've just got to activate it. And the way we do this is source, then we do the name of the virtual environment, /bin/activate. Now if you look down there at the start of your line in the terminal, you can see there we've selected that one and we're ready to start installing some modules. Alrighty, now that that one's set up, the way we install things is just by writing pip. Some users will work for pip, some users pip3, okay, just depends how you've downloaded Python. So do pip3 install, and then we're going to want to install 3 things. So first one is opencv-python. I will have a list of all these in the description, so you can just copy paste it over, make your life easier. And we're just going to let them run through the installation. So opencv-python's been successfully installed. Now we want to pip install CVZone, the second one. There we go, that's finished installing. And then we want to install Ultralytics. So we're going to do pip install Ultralytics. Now Ultralytics takes the longest to load, but still it's only like 30 seconds, so we'll just cut back when that's finished. Alright, that one's finished installing now, and as if you look back up at the file, there's no more squiggly lines, so we're all good to start getting into our code. Alright, so starting off, we're going to need to create an object model in order to find objects within a frame. And the way we do this is using YOLO, which we've imported from Ultralytics. And we're just going to type object model equals YOLO. And now the version we're going to be using in this video is YoloV10N. You can use any other version. I'll leave a link to their docs in the description, so you can look at any other version. But if you're using custom ones, you need to make sure you have the file saved already in your folder. But since we're using a base one, we're just going to do quotation marks YoloV10N.pt. So now when we run this code, it's going to download that model for us. Now that we've got the model set up, we want to actually capture a video stream in order to look for objects in. And so today we're going to use the webcam, and the way we do this is just cat equals cv2.video capture 0. Now 0 is the default for the webcam in Python. In languages like C++, I believe the default's 1. But now that we've got that set up here, so let's just comment capturing webcam video. Alright, so now that we've got that one set up, so we've got a model to detect objects with, we've got capture, so we're actually capturing the live video. Now what we need to do is actually get a frame of each video whilst the webcam is turned on. And so the way we're going to do this is by creating an infinite loop, doing while true. So this loop is always going to run until we interrupt it. And we're going to get two variables here. We're going to do frame captured and frame. So the first variable is going to store whether we've actually captured a frame or not, so true or false. And then the frame is actually going to store the frame we're capturing. And the way we capture these is by doing cap.read. So we're now reading the video stored in capture, or cap, sorry, which is what the webcam is getting. And then we're storing the results into these two variables here. And now to make sure it works, what we can quickly do is we'll do cv2.imShow. Now this is going to create a separate window showing us the frame that we've captured. And so we have to give it the name frame, pass it the variable frame from up here. And then just to make sure it actually opens and doesn't bug out, we're going to do wait key, cv2.wait key, and we're just going to put in 10 milliseconds here. And so now if we run Python file, it's going to take a few seconds on your first launch because it has to download the YoloV10 model. But we'll cut back to when that's all set up and going. Alrighty, there we go. So we know it's capturing our video webcam now, and it's showing us exactly what it's capturing. So now we're going to start the object detection process. And the way we're going to do this is we're going to go back into Visual Studio Code, click on down in your terminal here and do Control-C. That's going to interrupt your program and cancel it out for you. But just to make life easier for us in the future, what we're going to do actually is go down to the CV2 wait key. We're going to name it key press equals cv2.waitKey10. And we're just going to quickly write if key press equals 20, then we're going to break. So this is going to detect if we press the escape key, it's going to close for us. So we're just going to write closes, it's going to break out of the loop if escape is pressed. And then we're also going to add back up here at the top frame captured. So if it doesn't capture a frame, that's generally going to happen if there's an issue. And so what we want to do is if not frame captured, so if we don't capture a frame, we're also going to break out of the loop. So breaks out of loop if no frame is captured. And now we've got these set up, we can actually begin detecting objects. Alrighty, so now we're moving on to actually detecting objects, and the way we go about this is by creating a variable to store a list of all the objects we find. And that's going to equal to the object model we created back up here at the start, YoloV10, and we're going to pass it the frame here. Now this line of code here, if not frame captured break, is really important as well, because if we're not capturing a frame and we're not breaking out of the loop, it's going to pass over this invalid frame to this line of code here and it will break the entire program. So now that we've got those things sorted, we're going to begin iterating over the objects, and this is so we can outline, get the name, and how confident the computer is for each one of those. And so the way we're going to do this is for object in objects, what we're going to do is each object, when it's returned from YoloV10, has a list of bounding boxes. So this is where it's located and any information about it. And so we're going to have to iterate over those bounding boxes in order to get the information. And the way we do this is by doing boxes equals object.boxes. And then we're going to do for box in boxes. Now we can begin getting all the information. So first things we want to get is the top left corner and the bottom right corner of the bounding box, so we can display a rectangle. And the way we do this is x1, y1, x2, y2 equals box.xy0. Then we're going to go numpy.asType int. So we're getting the xy coordinates as integers, and we can use this to display a rectangle. So, and the way we display the rectangle is cv2.rectangle. Now we're going to pass the image, or in this case the frame, so frame. We're going to pass it the first position, so it's going to be the top left corner, which will be x1, y1. Then we're going to pass it the second position, which is the bottom right corner, which will be x2, y2. We're going to give it a color, so I like using red, so 50, 50, 255. And then we're also going to adjust the thickness here, just so it's easier to see, and we're going to make that equal to 3. So now if we quickly run this, run Python file, what should happen now is our webcam should open back up, and then it should detect me as a human, and it's going to outline me red. And there we go. So now it's detecting me, it's outlining me with a red, and what's next is we're going to get the name of what it's detected, and we're going to get the confidence value of that. So let's get straight back into it. But now while we're here, we can also test out our newly added hotkey. So if we press on escape, there we go. Cancels out of the program, and now we're back in VS Code, ready to keep coding. So now we don't have to keep going back and forth and doing Control-C. Alrighty, so now what we're going to do is get the name of the class and how confident the computer is that it is that class. And the way we go about the name is we're going to go class num. So when we detect an object, it actually returns an integer which is associated with a class name. So we're going to get the int first, and by doing this, we do class num equals int. So we're going to wrap this in integer, so this way it comes back as a number, and we're just going to do box.cls 0. Okay, so this is going to give us the number for the class, but the number is stored as a string, so we're just converting it into an integer by using this int function built in with Python. And to get the name now, we're going to do class name equals, and so the list of names is stored in a list called names under the object model we've created back up here again. And so we're going to do object model.names, and the way we access a value associated with an integer in a list is by doing square brackets. I'm going to pass class num, so that's the number we've just got given from the previous variable. And now this is going to return the class name as a string. And then next is the confidence, which is much easier to get. All we're going to do is confidence equals box.conf0. And that's it. So that's going to return confidence. It's going to be 0. Then 100 different numbers. And so what we're going to do about that is we're going to go confidence equals, then we're going to do confidence times by 100. Now it's really important that we do confidence equals confidence times 100, because if you do what you normally do in Python as times equals 100, it crashes out, it causes an error in the program, it does not work. So we're going to specifically state confidence equals confidence times 100. Now we're ready to display this information. Alrighty, now displaying the information is very easy. So we've been using the module CV2 in Ultralytics throughout this entire thing, but now it's time to start using CVZone. And what we're going to use CVZone for is CVZone.putTextRect. And then what we're going to do now is pass it the text we want it to display and the position of that. And the way we do that is by giving it a frame. So we're going to give it the string. So we're going to pass an F string. This just makes it easier to format our string. And so we're going to go squiggly brackets. We're going to go class name. Then I like to divide it with a straight thing. So coming out of the squiggly brackets, putting in a hyphen or whatever it's called. Now we're going to do squiggly brackets again. Now we're going to call our confidence value, which if you remember, we've times by 100. So it's going to give us a % from 0 to 100. But it's also going to give us a ton of decimal points. And so the way we fix this, we're just going to do :.2f. So this is going to round the confidence value down to 2 decimal places, so that way it's nice and tidy and not just a huge bunch of numbers on the screen. And then we're just going to go out of the squiggly brackets again. We're going to go %confident. Now we're going to have to give it a position. And the way we do position for this is slightly different to the rectangle. We're essentially going to pass through x, like an x coordinate and a y coordinate, but this time it's going to be in a list rather than round brackets. And so we're going to go x1. Now we're going to plus that by 8 just to move it a bit to the right so it's not right up against the left. And then we're going to do y1, and we're going to minus that by 12. And then one other thing we can pass through, which I like passing through, is the scale. So this is how big it is. I find scale equals 2. I find that's a much more readable and very easy to see scale than 3 or 1. So now that that's done, we can run the Python file. So there we go. Now if you look at it, it's doing exactly what it did before, except in the top left corner, where is it? There it is. It's saying person, and it's 95% confident. And that's pretty cool. Now if I get the phone back in here, we've got remote cell phone. This thing is, it loves detecting objects and giving it the wrong name, but it's very good with detecting humans, which is what this is about. So we're going to escape out of this. Now we're back into the code. We're almost done. All we're going to do now is So we're going to go down below the while true loop. Now this is just to make sure nothing stays attached after we've terminated the program. And we're just going to write cat.release. So we are releasing the video webcam. We're letting go of that, and then we're going to go cv2.destroy all windows. So if there's any windows open, it's going to destroy any window that's open. And that's pretty much it. Like, this is the code. It's very simple, straightforward to follow. Now I'm going to upload this to my GitHub. I'm going to comment on each line. So if you need to remember what to do or what exactly something is doing, they'll be there for you. And if you have any questions at all, please feel free to leave them in the comments below. I'd love to hear from you, and I'll help you guys out. And if you haven't checked out my first video, this is the exact same thing as this, but in 5 minutes, just rushing through it. No BS, no wasting your time. Please feel free to do so. I'll put that in the top right corner as well. And I hope you guys have a good day.